All right, how you guys doing? Ready for some party? All right, let's get disappointed first, maybe. So who's here? You're either in this room to learn a little bit of Node or to be pissed off about what I'm gonna say, right? So who's here to learn Node? All right, perfect. So the talk title is You Don't Know Node. And if you don't really like the talk title, blame Dave, because he picked it. In reality, the more correct term is you probably don't know most of Node. And I actually stole this talk title from my good friend Azat Martin. And if you don't know Azat, if you don't follow Azat, you should definitely follow him and follow all his good work on Node. Here's my beef. Most educational content about Node teaches Node packages. And there's probably nothing wrong with that because you probably need to use Node packages. But those Node packages actually wrap the Node runtime. And when you run into problems, you're most likely running into problems in the stack, in the Node runtime itself. So if you don't know the Node runtime, you're in trouble. So let's play a game. I'm going to put questions on slides, and you try to answer them in your head. And I'm going to attempt to answer them after that. And you just validate your Node knowledge. So let's try this one. What is the call stack, and is it part of V8? Who can confidently answer this question? Really? All right. So the call stack is definitely part of V8. And the call stack is the structure that V8 uses to keep track of function invocations. So every time you invoke a function, V8 places that on the call stack and keeps doing so, including functions that you invoke recursively. And once the invocation is complete, V8 is going to pop one function at a time and execute it. So it's very important to understand this in Node because you only get one call stack. So if you keep this call stack busy, your Node application is busy. So you want to keep track of what goes in the call stack. How about this one? What about the event loop? And is that part of V8? The more visual question here is, if I give you this diagram, which basically represents every Node application from beginning to finish, where is the event loop? The event loop is, who want to shout out an answer? Nope. libuv. The event loop is in this libuv library, which is an abstraction just to provide the event loop, among a few other things. But it's totally not part of V8. What is the event loop? Let's attempt to define the event loop. So one definition says it's the entity that handles external events and converts them into callback invocations. Maybe not very clear? Probably not. Let's try another one. It's a loop that picks events from the event queue and pushes their callbacks to the call stack. Maybe a little bit more clear, but still, not really. And there's a reason it's really hard to define the event loop or to just understand the event loop from an abstract definition. Because the event loop is just one part, one tiny part of a really big picture. And you actually need to understand this picture to understand the event loop. You need to understand that there is a V8 engine. You need to understand that there are Node APIs in the play. And you need to understand that there are some event queues. And the Node API are things like set timeout. You know that set timeout is not JavaScript, right? If I grep the source code of V8, set timeout does not exist. It's not JavaScript. It's a Node API, And in the browser, it's a browser API. So things like that are in the API land. The event loop sits in the middle of this picture. And it's like the organizer, the one who decides what goes where. And it's really simple. So when there are events in the event queue, and there are nothing in the stack, the event loop just pushes something to the stack. That's it. It's just a giant loop that does that. All right, let's try one more question. What will Node do when both the call stack and the event loop queue are empty? It will simply exit. So when you start a program, Node automatically starts the event loop for you. And when the event loop is done, there's nothing for the event loop to do, Node will exit. So to keep Node running, you need to place something in the event queue. So when you start an HTTP server, or when you start a timer, you actually put something in the event queue that says, keep running here, keep listening here, and keep the program running. All right, let's try one more question. Besides V8 and libuv, what other external dependency does Node have? These guys. HTTP parser, CRS, OpenSSL, and zlib. All of these are external to Node. They have their own source code, they have their own license, and Node just uses them. So you want to keep track of that. You want to know where is your program running. If you're using zlib, you're using some other library that's not Node, and you might run into troubles there. What about this one? Can Node work without V8? Who says yes? Yes, it can. You can run Node with Chakra engine. And I hear it's really good. I haven't really tested it, but I hear it's actually better than V8. Kudos, Microsoft. Let's get into more detailed questions, right? I know it's end of day, but. So you can, when you export the API for your module, you can do module.exports.g equal. You can also do exports.g equal. You can do module.exports equal something. You cannot do exports equal something. Why? That doesn't make sense. Because exports is just a reference to module.exports. And when you change exports, you change that reference, and you're no longer changing the API. You're changing some local variable. Cool? So let's keep on this topic. If you have module 1 that defines a global variable g, and in module 2, you require that module 1, and you try to access g, you get g is undefined. Why? If you do that in a browser, you definitely can access g. All the scripts can access any variable defined in any script. Why is it not the case in Node? Who knows the answer? Because every Node file gets its own IFI, automatically behind the scenes. In fact, if you drop into a Node script and you just console log argument, just one line, console log arguments, and you run that, what are you going to get? You are going to get some actual arguments. Why? Because that's a function. What you executed is a function, because Node wrapped your code in a function. So you'll get those arguments, those 5 arguments. One more related question. The exports, require, and module are all globally available in every Node file, but they are different. So when you expect a require object in one Node file, it's different than the other. But it's globally available. You just do require or module. How? Because of that magic IFI. That magic IFI is actually exactly that. It's a function that passes exports require module, file name, and their name. And those 5 magic objects appear to be global in your Node file, but they're not. They're just function arguments. So this require thing is really advanced. In fact, there are 5 major steps that happen every time you require a Node file. What are they? You can think of those as maybe Node interview questions, maybe not. But I would ask you that in an interview question. The 5 major steps are, when you require something, Node will attempt to resolve what you require. First stage. It will try to map that string that you required into an actual path on the file system. This path could be local to your node. It could be under your node modules. It could be under the node modules if you're a parent, and many other paths. So that's the first step. Map a string into a path. Then Node loads the content of that file, after it resolves it, into memory. And after that, it wraps the content with that magic iffy, the function. And after that, it evaluates the file, probably with V8. And once it's done evaluating the file, it will cache it. Which means the next time you require the exact same file, those steps are not going to happen. It will just read it from the cache. Related, how can you check for the existence of a local module? I don't want to run it. I just want to see if it exists. You can do that with require.resolve, which means just resolve it. Don't load it, don't evaluate it, don't cache it, just resolve it. If that's successful, the module exists. If it's not, it will throw an error that you can catch. All right, how about a harder question? Because those were the easy ones. What are circular modular dependencies in Node? Well, simple. If you have module 1 that requires module 2, and module 2 that requires module 1, what's going to happen? Who says you'll get an error? You will not get an error. Node actually allows that. And when module 1 requires module 2, since module 2 needs module 1 and module 1 is not done yet, module 1 will just get a partial version of module 2. And that leads to really cryptic scenarios that you are going to face for sure if you do that. So just be aware of that. All right, how about an easy question? What are the 3 extensions that will be automatically tried by the require function? We know .js, right? But the require function will also try .json and .node. So if you have a JSON file, you can just require it directly, and Node will actually take that JSON, parse it, and put it in a JavaScript object for you. You can also require a .node file, which is a binary file. So if you have some C code, you can just compile that C code into a .node file using some Node package, and you can just require the C code directly. You don't have to require the JavaScript. And that's a lot for low-level capabilities for you. So there's so much information about requiring modules in Node. And actually, this is your first step, to just understand this require concept. And I wrote about it in length. All right, let's get into a different topic. What are the major differences between spawn and exec? You might ask, what is spawn and exec? So you have Node and you have the operating system. And you can have Node run a command in the operating system and have the operating system give Node the output of that command. Easy, you can do that in all languages really. But the question is, spawn and exec both allow you to do that. What is the difference? And how significant is the difference? Because you want to pick one of those. And the difference is, spawn, by default, does not use a shell, while exec does. More importantly, spawn works with streams, while exec buffers the whole output for you. So from those simple differences, which one is better? Of course. Spawn is much better for both reasons. Because you don't want to use a shell if you don't need to. Because using a shell is actually a security risk. You might be vulnerable to shell injection. So if you don't need a shell, don't use it. And if you have a command that outputs a really big amount of data for you, you want to do that through streams. You don't want to do that through a buffer. You don't want to put the whole output of the command in memory. That's just a waste of memory. If you're getting the output of the command and you're doing something with it, you want to do it through streams, period. So you have a few other options. There's spawn, exec file, fork, and exec. And fork is an interesting one. We're going to cover some questions about fork as well. And I wrote about that too. All right, let's try easier questions. How can we make Node always use JavaScript strict mode? So I don't want to do use strict everywhere. I don't want to track that. I just want a strict mode all over the board. It's as simple as just doing that. Node -- use strict. And this particular argument is interesting because it's a V8 argument. It's not a Node argument. Node just relays that to V8. And V8 will start in script mode. And there are probably 100 more arguments just like that. Toggle that? You can toggle all the settings, actually, with modules in Node. It's a good question. What is process argv, and what type of data does it hold? Tell me you know that. You should know that. Process argv, when you specify arguments to the node command, those arguments get captured in an array. And all the argument values are captured as strings. So if you have numbers in those arguments, those numbers will be captured as strings as well. All right, let's try a little bit more challenging question. How can we do one final operation before a node process crashes? And can that operation be done asynchronously? The answer is, you can use the uncaught exception on the process object. So this uncaught exception is like a generic error, I'm crashing. What do you want to do? So you can do synchronous operation here. You cannot do asynchronous operations. Why? Because the event loop just gave up at this point and says, I'm not working anymore, go crash. So you cannot go back to the event loop. You can do synchronous operations. You can write to files synchronously. The more important point about uncaught exception, who used uncaught exception before? The more important point about uncaught exception is that you have to let the process exit. You should not emit that process exit line. That's not optional. You have to let the process exit. Because basically, at this point, when you're inside an uncaught exception, your application state is unpredictable. Something is terrible with your code. And your better option is to just reset. Do not assume that you can continue running. And the thing is, if you register a handler for the uncaught exception and you don't do process.exit, Node will not crash. It will stay running in that unpredicted state. So don't do that. Let's go with easier questions. What are the built-in dot commands that you can use inside Node's REPL? When you just run Node, you get a REPL. What are the dot commands? and you can see those with just dot help. And some of those are really helpful, like dot load, dot save, and more recently, dot editor gives you an actual editor inside your Node's REPL. All right, let's try an easier question, and I hope some of you know this, because it's really useful. What does the underscore mean inside of Node's REPL? Anybody used it before? It means last executed value. So if I run math.random, I get a random value. And if I want to capture that random value in a variable, of course I can't do math.random again, Node automatically captures that in the underscore variable, and I can just use that. Very useful, right? All right, a little bit more challenging. What's the difference between buffer allocate and buffer allocate unsafe? Sounds scary, huh? Because it is. Buffer allocate gives you a chunk of the memory and actually reset that chunks for you with zeros. Buffer allocate unsafe just give you a chunk of the memory, and you can read what's already in that memory. So you can actually leak information with using allocate unsafe, but it's actually faster than allocate because it doesn't do that reset. How about the cluster module? How does the cluster module work in Node? So the cluster module is to help us with scalability, and to help us particularly with the cloning scalability strategy. Not the other ones. There's more scalability strategies. The cluster module is just for the cloning scalability strategy. And the idea is really simple. You have a master process inside one server, and that master process forks multiple workers. And the requests come to your master process, and that master process determines where to send that request, to which worker. By default, Node does just round-robin algorithm here. And this is very helpful if you're scaling in one server that has multiple CPU cores. Because you don't need any tools. You can just use the Node cluster module. Few lines of code, you get that. But that comes with a price, of course. Any scalability comes with a price. For example, these workers have their own memory, their own V8, their own call stack. So you can no longer share things in memory. You can no longer cache things in memory. If you want to cache things in memory, you have to use a different entity with its own API and have all the workers work with that entity. So if you're using the cluster module, you want to be aware of that. And here's the thing. Many tools out there, for example, if you're using PM2, uses the cluster module by default, right? So if you're using PM2 in a multi-core CPU machine and you cache things in memory, you're just simply doing it wrong because some worker will not be aware of the other worker's memory. I wrote about that too. Been busy. All right, when is it okay to use the file system synchronous methods? Every file system has a synchronous method. So you've got write file, you have write file sync. Why would you do that? Sometimes it's okay. For example, in your initializing step, if you're just loading the server, it's sometimes okay to just do things synchronously because everything else probably depend on that data that you're doing it synchronously. That's okay, it's a one-time thing. But if you're doing a synchronous method inside a handler, like for example, inside the create server, that's 100% wrong. You should not be doing that because that synchronous method will basically block the event loop and nobody else can do anything on the server. So just be aware of that. All right, let's try easier questions. How can you print only one level of a deeply nested object? That's actually a JavaScript question, not Node specific. But it's really helpful. If you're printing an object that has multiple levels, a big nested tree, and you're just interested in the first level, you can use the console dir method and just specify depth 0. How cool is that? It gives you just the first level, and all the other levels will just be stubs. This is a function, this is an object. Cool? All right, next one is one of my favorite. How can you debug a Node program in Chrome DevTools? You can. It's as simple as that. In recent nodes, you just do node-inspect, and Node will give you a URL that you can run inside Chrome, and it's connected to the Node process, and you can use all the things, the good things in Chrome DevTools to debug your Node application. Who knew about this? All right, you guys are good. Let's talk about asynchrony. So we know that originally, Node is all about callbacks. We know now JavaScript has promises, which are cool. And as of recent, there's also async await to handle promises, which is cooler. Here's my question about callbacks. Can callbacks be synchronous? And the answer is yes. Of course. Callbacks do not indicate asynchrony. Just because it's a callback does not mean it's asynchronous code. You can totally do a synchronous callback. And sometime your function is going to be either synchronous or asynchronous based on some conditions. And that's actually bad. You want your functions to be either always synchronous or always asynchronous. All right, what about event emitters? What's the difference between using event emitters and using callback functions for asynchronous handling of code? What are event emitters? Well, event emitters are just objects. You require events, you get an event emitter. You can extend that event emitter if you want your own custom logic. But then, event emitters can just emit those strings, dynamic strings, any string. And you can register handlers to be invoked when those strings get emitted. Very simple. What's the major difference? Why can't we just use callbacks? Callbacks are like a special form of event emitters that you can register to once. So if you want code, if you want multiple callbacks to be fired for the same event, you want to use an event emitter. Because if you have multiple things to be done, it's a lot cleaner to have them in separate functions. If you want to do the same with callbacks, you have to drop into that single callback that you get and start doing if statements and stuff. So event emitters. And event emitters are actually super important because they're at the core of everything else in Node. Mostly all other objects in nodes implement event emitters. So they're very important. I wrote about that too. What's an example of a built-in stream in Node that is both readable and writable? Maybe an earlier question is, what is stream?
Terminal. Readable and writable.
Terminal? Socket, you mean socket?
TTY.
Yeah, totally. But some of the more interesting readable and writable streams are transform streams, like create cipher and create gzip, because they work with streams and you get to do something on streams while you're reading and writing them. So that's interesting. Streams are the next very important topic in Node. Because here's the thing, here's my global bold statement. If you're not using streams, you're doing it wrong. What's the difference between paused and flowing modes of readable streams? Readable streams can either be paused, in which case, which is the default, in which case you have to pull information out of the stream. You have to say, stream, I want to read from you. Or they can be flowing. And in that case, they're actually running. So you have to register events to capture their data. So by default, you get paused, and you can actually switch back and forth between paused and flowing, and sometimes that happens automatically by Node. So when you register a listener, Node automatically switches a paused stream into a flowing stream. And when you remove that listener, it switches it back. Totally different modes of streams. I said streams are super important because they're all over the place. Everything in Node is a freaking stream. HTTP responses, requests, file system read, write, zlib, crypto, TCP, child processes, standard input and output. They're all streams. And that's a really good thing because it allows you to not use memory when you don't need to. Working with big data doesn't require allocating a lot of memory in Node. You just use streams. And of course, I wrote about that too. But let me attempt to explain streams. That's how important streams are. I'm going to attempt to explain it to you right now. What are streams? Streams are collections of data that might not be available at all at once and don't have to fit in memory. So think of them as just arrays, but they're special types of arrays. They're arrays that you don't have. You get one piece at a time. So you don't fit them all in memory, and that's a good thing. Because if the array has 1,000,000 elements, you don't want to deal with the 1,000,000 element all at once. Get some elements, deal with them, write them. That's streams. So for example, we said examples of streams, there's readable, writable, duplex, and transform. And some examples, readable stream, you can do fs create read stream. You get a readable stream out of a file. Fs create write stream, you get a writable stream for a file. Duplex sockets are duplex streams, which means you can read and write from them with streams. And transform streams is the zip library, for example, the zlib library. So if you have a file that's, say, 10 gigabytes, and you want to zip that file, you cannot actually read the file to memory. Node will just not allow you to do that because the default buffer size is not that big. You have to use streams, which means you get one chunk of that file, zip it, write it to the zip file, but you're not done. You get more chunks, do that, write it, and you can actually zip this 10 gigabyte file by using maybe like 40 megabyte of Node's memory, using streams. That's how cool streams are. There's one thing that I want you to remember. All streams are event emitters. So you can register handlers on those streams and work with those. Again, event emitters, super important. Streams are hard. The global way to use streams is that, pipe. You get a readable stream, and you pipe it into a writable stream. That's it. Just remember this slide, because it's super important, the most important slide today. Readable.pipe on writable. And you can think of them actually as Linux pipe commands. You have multiple commands in Linux, and you pipe one on the other, and the other on the another one, and you get more powerful programs by doing so in Linux. The exact same philosophy. You get one node stream that is readable, you pipe it on a writable stream. And if that writable stream is also readable, you can chain and pipe it on another transform stream. In this picture, B and C have to be both readable and writable because we're chaining them. A can be just readable, and D can be just writable, but the others have to be transform streams, or duplex streams at least. And this is equivalent to that, just A.pipes B, and then B.pipe C, and so on. All right. So when we talk about streams, we actually talk about two very different things. We can be talking about implementing streams, but we can also be talking about consuming streams. And those are actually totally different. So if you're implementing streams, you require that stream library, the built-in stream library. That's when you need to require the built-in stream library, is when you implement a stream. But in most cases, you just use streams. You just consume streams because they're all over the place. So if you're inside an Express HTTP server, that res object, that's a stream. And you should know that it's a stream because now you can stream information to your clients. But you're only consuming that stream. That's why you didn't need to require streams. Cool? All right, so I'm doing this in more details on Friday. 7 hours of this, really. But that's all about I have for you. Thank you.